So the first time we really talked about uh, comparing different thing and different group and different timing started with the t-test family, right? So comparing two different group is independent samples t-test, comparing two different conditions for the same people or two different timing point, that's repeated measure t-test, right? So that was where we covered before exam, and then after exam we talked about Anova test, right? Basically, the basic form of one factor, one way Anova. So as what we visit status roadmap. So when we have one independent variable, but it has multiple group, more than two groups, so at least three, four, five groups to compare, then you cannot use t-test. It should be ANOVA test. ANOVA test really detect, is there any mean differences across different group. We want to detect that. That's one way and one factor ANOVA test. So starting this week, we're gonna look at some applied ANOVA test, especially what if we have multiple groups and multiple interacted groups, not only one categorical nominal variable. Instead, we have like two variables, like gender and ethnicity. How gender and ethnicity interact when you look at some of a policy attitude, for example. Then it is multi-factor ANOVA, two-way ANOVA. If you have two independent variables and three independent variables, they are all group comparison, then it is three-factor and three-way ANOVA. And then we will talk about repeated measures ANOVA. So in other words, expanded from repeated measures t-test and different versions of ANOVA test family. If we compare same people in three different, four different, and five different conditions or in time, then it's a repeated measures ANOVA. That's what we're gonna cover this week. So let me share our class note. So we are gonna talk about way Innova tests today, and then maybe start discuss the purpose of repeated measures Innova. And otherwise, we will just cover that on Thursday, and then we will really use SPSS and the data set, run both multi-factor ANOVA test and repeated measures ANOVA test, and see how we can interpret those numbers and how we can use those statistical tests for what kind of a variable. So we will really test it with the real world numbers. Okay, so let's just talk about the purpose of your hypothesis and what you want to do. So it really determines whether it's going to be t-test family or it is ANOVA test family and what you want to do. So that really identify and which way you should go. So when we just go back to what we used as example last week, when we compare across the different parties and group, political party affiliated group, how their political ideology are varied. Republicans are different from Democrat in terms of their ideological spectrum. That was what we wanted to confirm. That is one way in because we use one independent variables. But let's think about something like this. Okay, as you see in the table, you are interested people's political ideology. It's not only just based on only political party affiliation, or but what about their gender too? Okay, in American public opinion surveys for last 70, 80 years, okay, uh, gender It matters for their political, ideology, and political party affiliation. It matters for political ideology, and the status of ethnic minority and majority. It matters. So when your research question is about the multiple variables, multiple interactive variables and groups, how it determines some of the trend in your dependent variable, then it is multi-factor ANOVA. So one-way ANOVA only look at one categorical independent variables, and two-way ANOVA test is just like you see in the table here. You have two nominal categorical variables you want to look at, and how they combined together had different tendencies of a political ideology. Okay, so how are we gonna measure it? So that's multi-factor ANOVA. So last few weeks, we were here in these sections of statistical roadmap. So we were dealing with two variables, one independent variables, one dependent variables. And one independent variables, it is about the group, and the dependent variable is also about their tendency, mostly about the numeric variable. So when we have just only two groups to compare, it is, or two conditions to compare, it is a t-test family. And what we covered last week, it's one independent variable to categorical, but multiple group on their dependent variable. It was ANOVA test, one factor ANOVA test. But what we're gonna cover today, actually, we jump down here in the statistical roadmap, and we have two and more independent variables. There are different groups, okay, like gender, ethnicity, and partisanship, and all that. So multi-factors and how they interact each other to predict some political tendency, policy attitude. So your independent variable is a multiple groups and different numbers, I mean more than one independent variables. And then your dependent variable, how it really turned out as the consequences. In most case, in order to see those patterns, it's a numeric variable. That's where we use multi-factor ANOVA tests. So we are right here in statistical roadmap. Okay, so now we are at the in the test with more than two, so at least three different variables. Most of the case, multiple independent variables and about the dependent variable. So that's where we are right here. And then maybe we're gonna go back, if it is not today, on Thursday, about the repeated measures ANOVA. Okay? So again, as I promised, since the discussion after t-test is simple enough to compare the mean differences between two or different conditions in two different contexts. It's just simple enough for me to show the real number context. But as I promised that after since we started the discussion with ANOVA test, I don't expect you really do really hand calculation, mental calculation, or really using calculator to do anything. So we're gonna use the statistical, roadmap. I'm sorry, statistical software. They know how to run numbers. But the important thing is, I want you guys know what this statistical software, whatever the software you use, what this software they are doing to the question I ask and with the variables I use. Okay, so I will still go over what they are doing and what they provide you in the result table, so we understand and then we know how to interpret those numbers. Okay, that's what we're gonna cover this week. So let's see the table here. So we are interested, okay, still the some of the dynamics and differences and changes, but here in this case, it's mostly the differences by. Uh, so what we did for one way in about last week, across Democrat, Independent, and Republicans, and how their political party ID varied across different groups. So we compared the main differences, but now we had a one additional variable, categorical variable. What about if gender identity is combined with the political party affiliation, whether they are political ideology, the measures of a political ideology is fluctuating and different. That's what we're gonna look at. So when we really run the total number, ignoring gender, just measuring Democrat, Independent, Republican, we see party ID uh, uh, ideology tend to be more conservative as it goes from the Democrat and then Independent and then Republican. And also, generally, if we don't consider Democrat, Independent, Republican, but clubs that only look at female and male, we tend to have male voters. They are more likely to be conservative rather than female. That had been our public opinion for last several decades. Okay, so when if we run uh, one factor in a one-way Anova, that's what you're gonna find. Okay, but in your research, okay, in your research, let's think about the hypothesis. We want to know in two-way Anova tests. We want to know whether gender matters, party affiliation matters. That's what we call that as, okay, separate independent variable, whether each variable matters in their political party their political ideology. That we call that as a main effect. So each independent variables, they have a statistical differences in the main effect, mean differences, proportion differences, or whatever you're comparing. That's what we call as main effect. So that's the same way we do one-way ANOVA. Okay, if we run um, party affiliation on ideology, that's one-way ANOVA. They can confirm, and then also we can run the separate one-way ANOVA with the gender and on ideology. That's another main effect. Okay, so either you can run two one-way ANOVA or just simply run multi-factor ANOVA and to get that information. All right. But most of the time, okay, the purpose of multi-factor ANOVA test is that rather than simply run each one-way and multi-factor ANOVA, we just put multiple independent variables together. Why? The statistical and theoretical purpose is that you wanted to see whether there's interaction. Okay, so whether there's interaction between gender and party affiliation, whether it really changed their political ideology. Okay, when we kind of trace back to American public opinion, when we looked at what about female Democrat versus a male Democrat? What about male independent versus a Democrat independent? When we look at those dynamics, whether you believe or not, right? Um, Female Republicans are most likely to be conservative. Okay, so that is a fact. That is how American public opinion show that when gender and party affiliations are combined, and usually females are more likely to liberal, but when it's combined with the party ID, the female Republicans are most likely to be conservative. So there are interaction. If that is your part of your important research question, then you should go with the multi-factor ANOVA rather than all separate one-way ANOVA. So the purpose of the main reason of doing multi-factor ANOVA is you wanted to find out that interaction. You got that? Okay, so that is the purpose. That is the purpose. So then in this table, we see it is a two-way ANOVA, all right? So with gender and party ID. gender and party ID. So we looked at one main effect for gender that matters, and one main effect for part in the party affiliation, and then the main thing you wanted to look at is interaction between gender and party affiliation if there is any interaction goes on. Okay, so that's what we're gonna detect. What is able to be detected by multi-factor ANOVA beyond one way or one factor ANOVA. So that is the key. That is only the reason we do multi-factor ANOVA. So in real world research, I'm sure while you're doing literature review before writing up your hypothesis, again, both of you really brought out the good theoretically driven hypothesis so well. I love how to test it as well, and I will help you and we'll work together. But anyway, sometimes in the academic journal article, they say, well, this research has a 2x2 research design. Or they say, okay, it's a 2x3x5 research design. What that means is that you automatically know, oh, that's multi-factor ANOVA test. Yes, it is. Okay. So when they say 2x2 research design, that means that they have two groups in their first variable, first independent variable, and then 2x2, and then also second independent variable has also two groups. So that's what they meant. And also 2x2, that means it's a multi-factor ANOVA, but they have two variables, and each variable had two groups to compare. So that's a 2x2 ANOVA test. So you automatically know, oh, they use multi-factor ANOVA test most of the time, okay? Unless they have some tweaked or modified versions of modeling, but it's like 95%. It is multi-factor ANOVA. And also you can say 3x5 ANOVA test. So that means it's a two-way ANOVA test. First, independent variables had three groups to compare, okay, such as maybe party ID, Republican, Democrat, Independent. So they have three groups in the first independent variable, and second independent variable. Five means they have five groups to compare. Maybe religious denominate practice or ethnicity. Okay, so U.S. Census, we have six categories of ethnicity group, racial group, and sometimes five, sometimes they expand to 10, 12 different ethnicity, nationality group. So that means we have three groups to compare in, the first variable, five groups to compare for the second variables. So when you see those research design, it is all about multi-factor ANOVA test. Okay? Any questions so far? Good? All right. So the research question wise, okay, although your main uh, purpose and main hypothesis you wanted to prove is interaction, but most of ANOVA tests, we wanted to make sure, is it gender matters? Yes. Is a party ID matters? Yes. Then what about party ID gender combined together? Does it matter? So before we ask interaction, most of the research and multi-factor ANOVA tests, we wanted to confirm as independent variable itself. They are important statistically. Once it's confirmed, we kind of tackled interactive interaction between two, three, sometimes four independent variables. So it is more of a sequence of the hypothesis. What about main effect for variable one? What about main effect for variable two? What about main interaction effect between variable one and variable two? Right? That's how you raise your research question. So in the hypothesis, you want to see across um, the row when you look at the table I just brought for this class. Well, the row variable, which was the gender, they have some differences. What about the column variable? Of course, a different party ID, whether they have the differences. Null hypothesis means they will test it to nullify or falsify. So all the matters and means and differences are the same across row, across the column, and then also any patterns are going on across a different style. So your alternative hypothesis, alternative one means you really wanted to measure whether any row variable had a differences somewhere between group. In a column, variable had some differences between any group. Okay, and then you wanted to confirm there's interaction. So in order to put that in the real number, and this is actually the graph, I mean the table I brought from the textbook. So let's look at this. When you actually have two variables, A variables and B variables, when you compare A1, A2, or B1 and B2, just look at this table. When you see some differences between A1 and A2, so that means there's main differences in A variable, but not in B variable, right? What about the second table here in the screen? So we see A1, AB is different, and B1 and B2 is also different. So that means there's a main effect between a variable and main effect for B variable. Okay. But now let's move on to this is a very simple number, but in real world number, it's not that simple. Your eye kind of would just rolling and catching. It's not gonna get those statistical significant evidence, but it's just an example. But it's what you see between A1 group and A2 group. There's no differences. And between B1 group to B2 group, there's no differences. Okay. Oh, okay. So it's not statistically significant. We don't need to look at. But when especially you see the numbers and the patterns in the table, like, oh, just it's there. Okay, maybe right here and right there, in between those variable, level itself, it's not. But you see some patterns and maybe diagonal side, or maybe if there's more than like multiple cells, maybe right here and jump to the next right here. If you find any pattern across different cells in the table, then there must be some sort of interaction effect. So that's what multi-factor ANOVA can detect for you. Okay, so here by just looking at it at this simple number, we can see some interaction at the diagonal, just changes. That's interaction, right? So again, I'm not gonna really look just look at specific number, really calculate and just plug in numbers and not like that. But I still want you guys to understand the structures of multi-factor ANOVA. We learned that statistical analysis, the foundations of statistical analysis is consistent, right? The numerator usually really look at the changes and differences and what you want to measure that goes to numerator, and denominator anything the error. Okay, and just so we confirm through the t-test family and from one-way ANOVA. But let's see how two-way ANOVA, multi-factor ANOVA worked with the foundation statistical model. Okay, still it is alpha test. Multi-factor ANOVA test use alpha distribution table. But since it's a multi-factor ANOVA, multiple main effect including interaction, they run multiple alpha tests. Okay, so that's what we do for multi-factor ANOVA. So still, the alpha test, measure what if there is the differences across and between different groups. That's numerator. And what about all the error and any just changes or differences by chance? That should go to denominator. As most of statistical foundations and structures they try to measure. Okay, but there, since we have a just variable one, variable two, and then interaction, that's what we do for multi-factor ANOVA. So multi-factor ANOVA for two-way ANOVA tests, they actually run three different alpha tests. Okay, how? Okay, so we have F test. F, we call that as F ratio test because we compare the variance between group and variance within group. We compare the ratio. So we find any significant and more distinctive differences across group that we interpret that, oh, there is a group differences rather than any, just a mean variance by chance. So that's what we do. Okay, along with the total variance, we look at, okay, for example, gender. Let's see between male and female if there is some differences. Let's go to numerator of the first F test, but denominator is all variance among female and among male and combined. So divided by that, that's the first F test. Okay, so it confirms it's one way ANOVA, right? So it confirms the main effect of the gender. And the second alpha test, they run under two-way ANOVA test. What about party affiliation? So across Republicans, Democrats, and Independents, there are any mean differences. That's numerator again, and all those variability for Republican combined, Democrat combined, and Independent together, it goes as a denominator. That's the main effect. Also, it's just gonna be similar to one-way ANOVA, but it's a second main effect for the two-way ANOVA test. And then we cannot find by one separate one-way ANOVA, but only can find by multi-factor ANOVA, it's interaction. Okay, so what about gender and party ID together? So across those seven cells, any of those variants across those seven cells, and that goes to numerator. And again, all the variability across all, Republican, male Democrat, just combine all those variants for each cell, and it goes to denominator. That's interaction term that we confirm by multi-factor ANOVA. So, okay, okay, wow, that's so complicated. What is that? Basically, it's a variance test. What we do, okay, all the variance between and within for the gender, between party ID and across all party ID, that's for the main effect, and then interaction. So the same thing, what we really just kind of plug in numbers if we have a real number. But at this stage, it's not important that you really know number goes in here, there, and calculate. But the important thing, at least I want you guys to know, do not memorize. It's okay to forget about it. But the important thing for the F tests, T tests, and any other tests we're gonna cover for the rest of the semester, how, even the test table, the statisticians, they accumulate with the knowledge they have, and in order to read those tables and statistic value, you need to know degrees of freedom for denominator and degrees of freedom for numerator. Okay, so here let me just tell you, when we compare male versus a female, okay, male versus a female. How you do that? You fix one grand mean among different gender. So the degrees of freedom for the numerator variance for gender is between two, male and female, and then we make one grand mean. That's what we fix, and rest of the value can be anything. It's minus one. So that is a degree of freedom. That is a different from if your second variable is a party ID, right? It's three different groups, and then you will still fix one grand mean to compare the grand mean, how it is different from Republican, Democrat, and Independent. So it's still, subtract by grand mean. So that is degrees of freedom. That's what you need to know to read the distribution table. So what I'm saying here is that do not memorize it, but what I'm saying here is that the degrees of freedom for each app test under multi-factor ANOVA it varied depending on the group, the, the number of groups you are comparing. Okay, so what about interaction? So think about, okay, the tables you will look at: male, female, Republicans, Democrats for two gender, and independent. So we have a six cells. How are you gonna compare and how you gonna detect some those interaction? Then you're gonna find the mean overall mean, okay? But also you're gonna find each mean. Okay, each of those like a mean for Democrat, independent, I mean female Democrat, female independent, female Republican. So you're gonna have all those six of those the mean value to compare. Okay, so it might be less intuitive, but the degrees of freedom for the interaction comparison for numerator is total cell number, which is a 6 minus 1. But at the same time, we understand that, okay, we already done main, effect test. So from those, 5, the value 5, total cell number minus 1, brain mean. From there, you subtract degrees of freedom for the first variable and subtract from degrees of from the second variable. Okay, so that is a degrees of freedom for the interaction. If you have three groups, three independent variables, then total cell number minus 1, and then degrees of freedom for first group, first variable, second variable, and third variable, and subtract from the value. So that's how you can find the degrees of freedom for numerator for each main effect and um, the interaction. And then, of course, the total, uh, the variance, and their degrees of freedom is total sample size minus each cell, so which is gonna be minus 6. That's so what I'm saying here is that do not even try to memorize it, but think about that what you're comparing that really reflect what how statisticians assigned as a degrees of freedom. Okay, how many groups you're comparing, what you're comparing, is that among group or it's interaction? So that really varies how you can assess and with the different numbers of degrees of freedom. All right. So once you get that, that's it. That's it. That's multi-factor ANOVA. But again, like t-test, even g-test, t-test, and independent sample to t-test or ANOVA, one of ANOVA or repeated measures group comparison test, we had some shared assumptions. Okay. It's not numeric requirement, but theoretical assumptions. Same thing with the two-way ANOVA test. We wanted to make sure each group you are comparing for the main effect and also interaction effect. So across all these six cells, we want to make sure each cell they're randomly selected. And each members and each individual samples in each cell they're independent. So when we draw some of information out of that, that's representative. And also each cell on the dependent variable they are normally distributed. So when I had a Republican female, they are normally distributed among themselves. So with the value I fix and draw from there, it's reasonable number to compare Democrat males, for example. So normality is the theoretical assumptions we wanted to have. And then chromosine, it's the same thing. homogeneity of the variance. So again, it's the same kind of argument. We do not want to compare Texans with the Chinese. Okay, you think, oh my God, what we are doing, because automatically, theoretically, it doesn't make sense because we know the variance and variabilities among Chinese and Texans are different. But when we say, hey, what about comparing Californians versus Texans versus Floridians? That makes sense, right? Theoretically, at least. So that's what I'm saying here is homogeneity in variance. So when we compare multiple cells, they have a similar variability, at least theoretically. Okay, so that's the assumptions whether we can go ahead and do two-way Anova test or not. Okay, so once you have two-way or multi-factor Anova test completed, how you gonna write up what you're gonna report for the interpretation, the result interpretation. That is what you're gonna write up finally once you're done main analysis and when you wrap up your research paper for the class. Okay, so report first degrees of freedom for the group comparison, and then second degrees of freedom for the denominator for everybody, and then alpha value, and make sure that alpha value is located in the critical region, less than 0.05 or 0.01. So that means it is statistically significant. So according to two-way ANOVA, or you can say multifactor ANOVA, anything more than two-way ANOVA, multifactor ANOVA test, we confirm that it is statistically significant. The factor one is statistically significant. So gender matters for party ID. Okay, second alpha test to confirm that party ID matters for political ideology. And third hypothesis confirm that by interaction, that hypothesis test provide as one main effect, two main effect, and interaction effect. If the interaction effect confirm that, I will show you how the statistical software produce as like this variable one multiplied by variable two, how they shows you as a statistically the significance. Usually, most of interactions are calculated by multiplying those two variables together. It still affect some of the dynamics for dependent variable. So that's interaction. The same way how you're gonna write up, but in multi-factor ANOVA test, we actually looked at three separate alpha tests, the way I showed you. So first, second, main effect, separate alpha test, and third, alpha test for interaction. So you're gonna write out three different statistical result for two main effect and one interaction effect. That's how you're gonna write out for two-way ANOVA test. Okay. So now let's move on to before we wrap up two-way Innova test. Let's think about when you run a two-way Innova test. Okay, so it's clear that you wanted to look at the reason you do two-way Innova test instead of two separate one-way Innova tests because you want to know whether there's interaction effect or not. But let's think about when you have a three-way Innova test. More than two independent variables, but you have like gender, party ID, ethnicity. Four-way Innova test. Gender, party ID, ethnicity, and maybe their socioeconomic status. Three different categories of socioeconomic status. But you have four, main effect. Then let's think about the interaction effect. Then automatically, if you run full um, ANOVA test with the multi-factor ANOVA, so for three-way ANOVA, for example, they will provide you interaction between A and B variable, B and C variable, A and C variable, and ABC. But if you have a four-way ANOVA test, it's much more, many more interaction term. And so here, three-way ANOVA test, they will provide you 7 different alpha tests. Okay. So what I wanted to say here is that when you run multi-factor ANOVA tests, you have authority to select which interaction, of course, whatsoever, in order to run ANOVA test, in order to report interaction and their statistical significance, you need to report all main effect first. That's more of kind of a manner. See, unless your main effect is significant, not significant, without that discussion, you don't really necessarily talk about the interaction between the main effect, right? But when you come down to main effect, you have authority to choose. Theoretically, there should be interaction effect between A and B, but not between B and C. That what you're gonna do in real world analysis and real world data set, you can actually select, oh, I wanted to report the interaction for A and B, but not B and C, but A by B and by C. So all three variables together. So that's a two interaction terms that I wanted to uh, report, and that is theoretically important for my hypothesis and my research. Then just you can select which interaction you wanted to run. And most of the statistical software, they have option provide you which on the interaction you wanted to include and control, unless you want to have a full set of interaction tests with each app test for each interaction test. Okay, so we'll test that on Thursday class and choose which if you have any tendency among different interaction term. Sometimes they had a more theoretically driven that is more interested in, rather than you run all interaction terms. So that is more of your choice. That's completely fine. Don't report all the interaction, but you have actually run the selective interaction term. Okay. Okay, so now I will just go over uh, the differences. Okay, the differences, and when the purpose of the hypothesis, when you move from multi-factor ANOVA test to repeated measured ANOVA test. Same way, you guys done well for the question from the exam. I found that when it is a time for you to use independent sample to t-test versus repeated measured t-test, it's only depending on it is your sample. Okay? Your samples are cross-sectional or your samples are longitudinal. Same kind of a decision you should make. If your samples are across different three cross-sectional, so partisanship wise, ethnicity group wise, and different geopolitical location wise, then it's multi-factor ANOVA. But if you test the same group for time one, time two, and time three, okay, time three, then it is repeated measures ANOVA because it's the same people across different timeline and conditions, a different stimuli effect. That's a repeated measures ANOVA. The differences between repeated measures t-test and repeated measures ANOVA test is whether it is between two different time, like ANS data set before election and after election, that's one of its in repeated measures t-test. But if you have time 1 to 3, condition 1 to 3, more than two conditions to compare for the same group, then it is a repeated measures ANOVA. So again, I will just show you the structures of the data, analysis of what you do, and structurally. and whether it's just still aligned with the foundations of statistical analysis. So only the matters between repeated measures ANOVA and multifactorial ANOVA is that whether the individual differences are counted or not. That's just the key differences, and rest of them are the same. So I will just stop here, okay, and I'll just talk about the rest of how and we identify the repeated measures ANOVA test and what kind of the theoretical structures they use. Once we cover that on Thursday class, we're gonna just run multi-factor ANOVA test. I'm sorry. Yes, multi-factor ANOVA, at least two-way ANOVA test that we'll run, as well as repeated measures ANOVA test. That's what we'll run, and then just rest of the Thursday class, we're actually gonna visit your own variables from GSS dataset and ES dataset. We're gonna clean together so you can share your, if you have a question and you show me and how you want me to do, and you can share your screen and we can go step by step. So it will be more of one-on-one and two, three people with together and run some numbers and clean up your own data and own variable. That's what you're gonna do. Okay? So I will stop because I want you digest what is multi-factor ANOVA before we move on to multi-measures and repeated measures ANOVA test. So up to this point, any question? Any question? All right. Okay. So unless you have a question, and I want you to just, you know, wrap up. And again, I do not mind. You just kind of help the theoretical driven hypothesis submitted. But practically, how we may mildly modified in order to really make it as more testable. We can work on it later, but the due for the hypothesis is the midnight tonight. Okay, so wrap it up. And so that's what I want you guys to work on. So before I let you go, any final questions about two-way multi-factor ANOVA test and hypothesis that is due tonight? Any question? Okay. Otherwise, enjoy wrapping up your hypothesis and state it out concisely and the corrective statement and testable and theory driven. And once we are back on Thursday class, we will move on with the repeated measures in ANOVA and how actually we just do the step by step and how to run those tests. Okay? All right. Have a great afternoon. Do not forget that this evening sometime it's gonna be we're gonna hit by the front cold front. So be ready for it and wrap yourself. Do not get sick, and I will see you on Thursday. Hey.
Thank you.
You're welcome.
Thank you.
Thank you.